Hi there, welcome back. Welcome back to the Breisgau 8. This is the SABA Breisgau 8. I left off last doing the AM alignment, and now I'm heading for the FM alignment. I've done quite a bit of research, found a few sort of anomalies in some of the descriptions, which I'll show you as we go along. But I think I'm ready. I hope I'm ready. This is a little bit unusual. Or rather not as usual as some of the simpler sets, but nothing we can't get over and get done. So let me just talk you through basically what it is that we are doing and how we're going to do it, and how I have interpreted some of the descriptions they give on here. And this is the alignment instructions in English, which I have for the, I believe it was the Freiburg 8, was it? Freiburg. Doesn't matter. It's in English, and I've used this basically to try to understand the German instructions, which I have for the Breisgau. And I sort of compare what the German instruction says here to what it says in English, and I sort of do a correlation and translate what they're trying to say on the Breisgau instructions, because they are different. The layout and the coil numbering and everything else is different. So I have to always be careful that I don't get these things mixed up. But let me show you what it is we got here. Now here are the alignment instructions for the Breisgau, and we've got as far as the AM alignment. So now we're heading for FM, and the start of the FM alignment is here. What it tells us to do, and I'm going to read the English version, but what it tells us to do is press UK and automatic off. So select FM and automatic off, okay. Then connect a voltmeter with an input impedance of greater than 0.5 meg. 10 volt full scale reading to test points X and Y. That's on that socket. We know this one is X. Y is that one, which is also ground. So we know that it's between X and ground, and here's that voltmeter. Then it says connect a 0 center microammeter to test points X, Y, and Z. Now this is a little bit confusing if you didn't have this drawing. What they mean is you connect a resistor, 200K resistor or 100K like the one I've got built up. You connect that between X and Y, in other words, between X and ground. And the center point of those two, you connect the microammeter to that and also to Z, which is that point over there. So I've done that. And then it says signal generator, connect the signal generator, 10.7 megacycles, unmodulated, output cable matched through it's 1 nanofarad, 1000 microfarad, to the low side of C205 and chassis. Now this is where it gets a bit complicated, because it says here point T. It says point T, C schematic, and ground. C205, what does it say in English? Detune C205 until the noise voltage disappears at the voltmeter. For this, set the receiver to 92 megacycles. So what are they trying to tell us here? And where the hell is point T? The problem is we have no point T, and if we look at the low side of capacitor 205, this is what we come up with. As expected, C205 is within the FM front end CAN. More specifically, it is here. That there is C205. The low end of C205, as I understand it, would be here. But there's no point T on the schematic, and believe me, I looked. Until I thought of something else. I went and looked at the other schematic. Now here we have the Meersburg schematic, and if we go to the same region, here's the point T, very clearly. So this one has got T, the other one does not, and it is on the low side of capacitor 205. What are we doing here? Well, as you can see, this front end is rather different to the usual ones that we've had. The usual ones have had one tube which acts as a mixer, oscillator, RF amplifier, you name it, it does the whole business. This one has a separate RF amplifier. This tube here is RF amplification. So it amplifies the signal coming in from the antenna through that, basically that coil. It induces the signal on here, it gets amplified with that triode. That's an EC92. And that then is created, or the load is created across this coil over here. And this coil over here then, you see, goes off. If you can follow that line there, it goes off to the grid of that triode. And we know from all the other stuff that's down here that this is also the oscillator. So this is an oscillator mixer, and it is taking the signal coming in from the front end, which is the result of it going through that coil with transformer action effectively. It takes it through there, and it's amplified at this point, remember, because of this. It takes it into there, and it pumps it into the grid of the EC92, which in turn is creating or producing a oscillation, or a local oscillator frequency, which is equal to that frequency that you've tuned at the front here, plus 10.7 megahertz. That's the IF frequency. So it does the mixing, and the result of that is it comes out of here. Where does it come out? Well, it basically goes through at 10.7 megahertz. So we know this is acting as a mixer oscillator. And the reason we are feeding it to the bottom of C205 to here is that we want to get it through to the grid. We want to get that 10.7 megahertz that we're going to use for the IF alignment, all right, to get through the grid, to the grid of this tube, to get through it completely, and then in turn get sent on to the radio, to the rest of the radio. So we are feeding it here because it can go through that coil. It actually can go through that capacitor as well, but it can go through that coil to there, through that capacitor. That's a 12 picofarad capacitor, pretty small, and it gets to the grid. That's all fine. In the past, what we've done is we've lightly wound a coil or a wire around this tube. So we've lightly coupled to the head of this tube, and we can do the same thing, it'll work. But they're giving us some more direct instruction. What surprised me is that there's no point on that can that tells us it's point T. So I decided to open it up. And what I found is that point T is the body of that capacitor. This is an adjuster that you're going to do when you do an RF alignment, okay? So the actual screw that you're tying in, which is accessible to the front, to the top, is actually that negative point. And to prove that, I've opened it up, and I will show you. And I've measured the resistance between there, or I found the screw, the top of the screw, measured the resistance between that and what I know to be that point, because there's a 10K resistor and a 1.8 nanofarad capacitor moving off, and it's a short. So that's the point we want. And why do we have to detune this guy till the noise voltage disappears? Well, what we're doing is we're making sure that while we're sending 10.7 megahertz into here to act as the IF frequency that we're going to adjust everything to, we want to make sure that nothing's coming from the front end. Remember, this amplifier is working all the time. We don't want anything coming in from that end. So what we do, and the way this works is when it sends signal through, it is tuned to go through with this inductor and capacitor circuit, this tank circuit. That inductor, that capacitor, tunes to the middle of the FM band, which they're giving us as 92, more or less the middle of the band, and it allows all the signals that are amplified within that range to go through. So it's basically telling us detune this so that this part of the circuit, the RF front end really, doesn't interfere with the signal that we're sending through. You know, you could get spurious transmissions that come through exactly where you have the dial arbitrarily pointed. So they tell you, put it at 92 and detune the bloody thing. They'll tell us later, obviously, to peak it, which we'll see in the RF alignment instructions. But in the meantime, they say, detune it, so the only signal that's going through is the 10.7 you're feeding to here. So that goes into there, and then you get the usual story of having to tune the various IF transformers. There's one over here, there's one over here, the FM section obviously only. There's another one over here, and then there's the final. Was that the final already? Yeah, that's the final one. That's the ratio detector or discriminator one. Yep, that's over there. So you tune all these filters. The numbering is different on the instructions I have in English versus the ones in German, but the instructions are basically the same. So let's go back to the Breisgau and see what they tell us to do. Here we are. They tell us to send a signal from the signal generator, 10.7 megahertz, unmodulated, through a 1 nanofarad capacitor to point T, in other words, to that capacitor screw, which is going to be a bit of a challenge trying to get it connected there, but anyway, we'll find a way. And detune and all that stuff. Then they go straight onto here. Now this is the last IF transformer. This is the ratio detector transformer, and I'm going to read the English version, but remember, this thing basically relates to what we have over here, and the numbers they give us are different. So they say, adjust coupling subcritical with K 2325. So that one there. So these top three here are the ones we're going to be handling for now. Adjust coupling subcritical. So you unscrew that top one. Make sure it's the right. Yep, that's the right one. Then you adjust the primary circuit 601, which is the bottom one of those three. So it's that one there. Adjust that for max. Where are we? We're max on the voltmeter. Okay. And then you adjust the secondary, which is that middle ball over there. That middle ball over here. Adjust the secondary to 0 at the microammeter. Okay. So we'll do that and see how we go along. But before that, let me show you what the setup is. Now, according to the alignment instructions, when we finally have to adjust C205, it's that guy over there. So what I did is I just removed this, and I can see that that is the cap that we need to adjust. And I've also determined that this top of the cap, in other words, the screw itself, the metal screw itself, is the connection to that point there, which is where 10K resistor goes off and 1.8 nanofarads. So I need to feed the signal into there, and I need to do this from the signal generator through a 1 nanofarad capacitor. So I need to touch that there, but I need to do this with a cap on. So I need to put that back on. I only took it off just to see what I was basically aligning. Put the cap back on and we'll be ready to go. I believe I've got everything set up correctly. I've got the minus 4.5 volts cancelling out the AGC. I've got the voltmeter connected where it's supposed to be. I've got the center zero microammeter connected where it's supposed to be. I have connected the signal generator to the top of that capacitor, as I mentioned, through that 1 nanofarad capacitor. And I've got 10.7 megahertz coming in. Now, I know it's coming in because if I put modulation on, I can hear it. I'm not going to put modulation on. I've got the signal fairly weak. This thing is reading, what is it, 6 volts? So it's below the 10 volt range they talk about. So that should be fine. And now I'm going to do what I have to do, which is to annul or loosen, decouple that transformer. Now what happens? Let's see. So here we go. Critically uncoupling that transformer. We're getting the meter going down. It's not going down anymore, so I think we're there. And now I need to adjust, which one is it, the end one? I need to adjust this one here to a max on the voltmeter. So let's do that. Whoa. Oh, that's going up. There's our peak. There's our peak. Good. Now we need to look at the microammeter. And as we can see, it's not center zeroed. It's actually down, and we need to adjust the middle one for center zero, that one. It's very far down. See if I can reach it with this guy. Don't seem to be able to get it to center zero. It's strange. I just changed the amplitude of the signal. Certainly can't get it centered. I wonder if the coupling has got something to do with it. Or maybe that's got something to do with it. See, that's going to the center, but it's reducing the... Seems to be absolutely no influence here. So it's just me touching the signal generator's cable. Let's give it a signal. I'm going to try something else. I'm going to try it on the scope and see if I can't do it the old way, which is to try and get the best sine wave that I can. So I'm going to peak this guy here. Okay, that's peaked. Now I'm going to try the scope and see if we can't get that to give us some information about the quality of the sine wave that's going through. Now if I keep an eye on the scope, see if I can't improve that. I need to get a good sine wave here. It could be just too strong a signal. Let's try that. Could the coupling be the problem? That's better. That's much better. There's my perfect sine wave. There's my peak amplitude. Let's see what I do about the coupling now. The volume down a bit. I believe I've got this critically uncoupled. Turn off modulation. Turn on modulation. I want to see if I can find another point further down. I don't think so. Seems to be it. Now this is coupling it a bit more. See if we got our peak. That's at the peak. That seems to be about it. If I couple it too much, it drops again. Drop the volume a bit. That's about the best that I can get. Let me try something else. Let me try the modulation on AM. I've got now AM modulation, and the idea of this discriminator alignment is that you get the lowest AM modulation possible. So here we are. It's at the minimum, which is where it was when I had FM modulation at the maximum. So it seems to be there. AM modulation, the volume up, try and get the minimum. That seems to be the minimum. That is a roundabout way of doing it, I believe. Not the way they tell us to do it, but for some reason I can't get the zero crossing, the 0 microammeter slap bang in the middle. Let me show you where it is. This is where it is, slightly off center. And if you put it on 100 microamps, it's even more off center, but I just cannot get it to the center for some strange reason. Okay, well, put off modulation. Let's go down to the meter again. We're looking at our meter again, and the next thing they tell us to do is 501. Okay, so basically they tell us to do the same thing with this guy here. Critically decouple. You can see it going down. Fair enough. Let me give this a bit more oomph. Okay, now we adjust these two for maximum. Seems like they were, or that one was certainly close. That's a peak. That one there. I have to do it with a proper screwdriver first. Doesn't seem to affect it actually. Normally you can't use a metal screwdriver for this. Okay. There's our peak. There's our peak, and now we critically couple. Take it to the max. Seems to be about as far as it'll go. Unwind a little bit. Okay, now we do the same with this guy here. Critically uncouple. And peak that to a max. Give it a bit more so that I can actually see it. I've given the signal a bit more amplitude. It's pretty much there. That one. Oh, that's a bit of a rise. We've got a bit more there. And now we critically couple. I'll drop the amplitude of the signal generator again. Drop that a bit. Now I'm going to keep critically coupling. There's the top, unwind a bit, and we're there. And now we've got the last one, which is, it's actually this guy over here. And the coupling is, I believe, the bottom one. So uncouple. No, is that the coupling? I don't want to get myself shocked on here. So we're decoupling this guy. Let's do an adjustment now. Oh, got a bit more there. Let's peak. This one was peaked. Okay. And now we recouple it. Again, try not to get shocked. It's always a good idea to try not to get shocked. Okay. That, my friends, was a rather hasty attempt at doing the FM alignment. And it carries on, but I want to do a bit more studying on why that thing does not, why it doesn't actually align with the center zero microammeter. I'm not sure why it does that. Okay, I'm going to stop this here for now because I want to just have another closer look at what I've done. So far, I want to test the reception, see how that goes. I know more or less how it was when I started. I want to see what it's like now. Well, it actually sounds pretty good. Not bad at all. Perfect. There's not much else here that's perfect reception where I am. Okay, what have I concluded? I'm not 100% sure that this is perfect. I notice that some of the stations here in the middle of the bands, it depends on the time of day. I don't get them perfectly, but I think I perhaps should get them better than I'm getting now. So something might be off in what I've done. This one here, it's just voice, and it's coming through fine. Not worried about that one. But I'm not sure that this is as strong here as it used to be, and obviously it should be stronger if I've improved any of those alignments. So I'm going to think about it for a while, revisit the problem, revisit the challenge, and get back to you when I've discovered something new. Okay, well, this is another step towards restoring this radio that I don't have a chassis for, and I have a broken dial glass. Anyway, it's fun. It's fun. I hope you've got something out of that. If you have any input, please leave comments below. They're always useful. My memory on how to align this one is very vague. I did the other one a long time ago, the Freiburg 8. So this is really trying to re-experiment and rediscover what I already knew. That's going to be it for now. I'll carry on with this and get back to you as soon as I've got something new to report. In the meantime, as I've said when I started this radio, this restoration, I might have a few other things in between. Thanks for your company, and if you enjoyed that, please click like, share, subscribe, and all that jazz, and I'll see you back soon for another video. Thanks for watching. Bye for now, and stay safe. Just got to revisit this because I've just tried something. I have removed the meters there, all the measuring devices that were stuck on there, and I've just realized something. When I removed the two resistors, you know, the ones that go to the center of the micrometer, these are 100k each. Now there they tell us to put 200k each. When I removed this thing suddenly went up. Perception went way up. So I think there's a problem here. There's a problem with the way I was measuring it. I took it for granted that putting those 100k resistors would be fine, and it seems that they were dulling the band pass. In other words, they were actually affecting the way that I was measuring this or doing the alignment of that core over there. So, as I said, we live and learn. I'm going to, again, sign off for now, revisit this problem and see what I can discover. Thanks again. Bye for now.